For generations, life near Naples moved quietly, even as 500,000 people built homes atop the buried Campi Flegrei supervolcano. Now, in 2025, fishermen report the sea itself bubbling, just as ground uplift hits 1.4 meters and a magnitude 4.6 quake rattles the caldera's red zone. Scientists fear these aren't isolated warnings, but signs that Campi Flegrei is waking up. What happens if the world's most densely populated volcanic danger zone runs out of time? Just after dawn, boats drift in the Bay of Pozzuoli, nets hanging slack, when a fisherman named Salvatore notices something wrong with the water. The surface, usually calm and glassy, churns with clusters of bubbles. At first, he thinks it's a school of fish, but the pattern is too steady. Patches of sea fizz and swirl in places where nothing should move. He grabs his phone and starts recording, the date flashing on the GPS log, September 21st, 2025. The bubbling stretches for meters in every direction, rising from the depths in silent, restless bursts. Word spreads quickly along the docks. By midday, dozens of fishermen have logged similar sightings, pinning GPS coordinates along a jagged arc between Pozzuoli and Baia. Some mark the spots on digital maps, others scribble notes in battered logbooks. They talk about the smell, sharp like rotten eggs, and the way the water feels warmer near the bubbling. A few older men shake their heads, recalling stories their fathers told about the sea acting strange before the Monte Nuovo hill appeared centuries ago. Port authorities receive a steady stream of calls. Crews report patches of water that seem to boil, even on windless days, and a haze that sometimes hangs low over the surface. One captain, used to decades of routine, says he's never seen anything like it. Not in summer, not in winter, not even during the seismic swarms of the 1980s. Local seafood catch logs show a drop in fish near the bubbling zones. Some nets come up empty, as if marine life is avoiding these spots. None of this is rumor. The fishermen's GPS tracks and daily logs provide a record that scientists can't ignore. The sea is bubbling, and it's happening now, visible, persistent, and spreading. For those who work these waters, the question isn't if something is changing underneath, but how deep the change runs. Beneath the bustling streets and pastel buildings west of Naples lies a volcanic structure unlike any other in Europe. Campi Flegrei is not a single mountain, but a caldera, a sunken 8-mile-wide basin formed by ancient eruptions stretching nearly 13 kilometers from rim to rim. Unlike Vesuvius, which rises in clear view, this volcano hides in plain sight, its boundaries overlapping with modern neighborhoods, parks, and the crowded waterfront. The land itself is the volcano. Cracked pavements, steaming fields, and clusters of vents scattered among residential blocks and Roman ruins. This caldera is home to more than 500,000 people living directly above the most dangerous zones. The so-called red zone covers towns like Pozzuoli, Pozzuoli, Solfatara, Solfatara, and Baia, where narrow streets wind between old churches, apartment blocks, and bustling markets. Each day, over 500,000 residents go about their lives, unaware or unwilling to dwell on the fact that their homes sit atop a volatile system capable of landscape-altering change. Beyond the immediate red zone, another 6 million people live within reach of the caldera's effects. Naples itself, sprawling suburbs, and the coastal towns lining the Bay of Naples. Unlike remote volcanoes, Campi Flegrei's hazard is woven into the fabric of daily life. Schoolyards and football fields cover ancient craters. Commuters cross invisible boundaries between stable ground and restless earth. The sheer number of people at risk makes this the most densely populated supervolcanic zone in the world. Every street, every building, every family stands on ground that has risen, sunk, and fractured over centuries, sometimes in slow pulses, sometimes in abrupt, violent bursts. The scale of potential impact is measured not just in geological terms, but in the lives, homes, and histories built directly atop the caldera's hidden rim. Ground in the Campi Flegrei region has not stood still. Over the past 20 years, the land beneath Pozzuoli and its neighboring towns has lifted by 1.4 meters. a rise so steady and relentless that old doorways now sit crooked and ancient stone steps tilt at odd angles. This uplift is not a slow-motion relic of the past, but an accelerating phenomenon, measured by satellites and ground sensors with each passing month. In the last year alone, the rate of vertical movement has doubled, pushing the land upward by several centimeters in just a few months. Residents have learned to watch for subtle changes: a gate that no longer closes, a crack that widens overnight, the faint groan of shifting foundations. The Earth's motion is not silent. Since 2023, more than 2,000 small earthquakes have rattled the caldera, most so shallow they feel like a train rumbling just beneath the street. On June 30th, 2025, a magnitude 4.6 quake struck at dawn, shaking homes from Pozzuoli to Naples and sending hundreds into the streets in their pajamas. This was the strongest earthquake recorded in the region's recent history, and it left a trail of fractured walls, buckled roads, and anxious conversations echoing through the red zone. Emergency crews inspected bridges and schools for hidden damage, while geologists mapped the event's epicenter just a few kilometers below the surface, far shallower than most quakes in Italy. Seismic swarms have become a near-daily occurrence. Some last only minutes, others stretch for hours, with clusters of tremors radiating outward from the caldera's hidden faults. Each swarm is tracked in real time, plotted on digital maps that reveal a restless web of movement beneath the city. The pattern is clear. Earthquakes are becoming more frequent, more intense, and more closely tied to the areas of greatest ground uplift. For scientists, these measurements offer hard evidence that pressure is building below, a mechanical unrest that cannot be dismissed as background noise. The land is rising, the earth is shaking, and the system beneath Campi Flegrei is anything but stable. Thermal cameras and gas sensors now record numbers that once belonged only to scientific models, not to daily life. At the Tyrrhenian and Solfatara vents, temperatures have soared past 128 degrees Celsius, with some instruments logging peaks up to 165. These are not isolated readings. They are part of a pattern confirmed by a decade of near-daily monitoring. In 2015, carbon dioxide emissions hovered around 2,000 tons per day. By 2025, the rate has doubled, surpassing 4,000 tons every 24 hours. This is the highest ever measured in the caldera's modern history, and the increase has not been gradual. Instead, the past 2 years show a steep climb, with gas fluxes rising faster than any previous decade on record. The heat is not confined to remote fumaroles. In residential neighborhoods near major vents, ground temperatures have reached 50 degrees Celsius, hot enough to warp floor tiles and force families to abandon bedrooms closest to the walls. These numbers are logged by handheld devices and thermal drones, not just anecdotal reports. The INGV's official bulletins now include weekly updates on vent temperatures and gas output, treating each new spike as a potential warning. The doubling of carbon dioxide emissions is especially concerning. Carbon dioxide is invisible, heavier than air, and accumulates in low places, cellars, basements, and the hollows beneath city streets. In some homes, indoor carbon dioxide levels have spiked to dangerous concentrations, triggering alarms and forcing evacuations. Scientists track the rate of change as closely as the absolute numbers. The acceleration itself is a red flag. When both heat and gas emissions rise together, it signals that pressure is building beneath the surface. The caldera acts like a sealed pot, and every new measurement is a reminder that its lid is straining under the force below. These data points, 128 degrees at the vent, 4,000 tons of carbon dioxide per day, 50-degree ground in city parks, are not just statistics. They are early warnings, quantifiable signs that Campi Flegrei's volatile system is growing more restless by the week. Inside a modest apartment on Via Solfatara, the Mascolo family measures each day by the latest signs of volcanic intrusion. The outer walls radiate heat, so much that touching the plaster leaves a sting on the palm. In the kitchen, yellow sulfur crystals have begun to creep along the baseboards, dusting the tiles with a brittle crust that crunches underfoot. Their youngest daughter, Lucia, started sleeping in the hallway after her bedroom grew too warm to bear. At night, the family runs fans pointed at the walls, hoping to push back the heat that seeps in from below. Even with these efforts, the floors have warped, bending around the edges like wet cardboard left in the sun. Last winter, the Mascolo spent over €6,000 on repairs, scraping away sulfur, repainting with heat-resistant coatings, sealing new fissures with industrial caulk. Within weeks, the cracks reopened. Insurance adjusters, when they finally arrived, refused coverage. The policy's fine print excluded all damage attributable to volcanic phenomena, leaving the family to shoulder each expense alone. Receipts for repairs pile up in a kitchen drawer, a quiet record of a battle they cannot win. In the living room, the air sometimes carries the sharp tang of sulfur, especially after a rainstorm. On bad days, the children complain of headaches and a metallic taste on their tongues. The family keeps windows cracked year-round, even in the cold, to vent the invisible gases that build up overnight. Each morning, they check the carbon dioxide monitor on the wall, the only warning they trust more than their own senses. The Mascolos are not alone. Neighbors swap stories about scorched wallpaper and warped doors, about nights spent sleeping on couches or in stairwells. The cost of living above Campi Flegrei is measured not just in euros, but in comfort lost, routines disrupted, and a constant, low-grade fear that seeps into every corner of daily life. Artificial intelligence now parses the smallest tremors under Campi Flegrei, tracking thousands of microquakes that once blurred into background noise. In 2025, a breakthrough came when Dr. Giovanni Chiodini and Professor Christopher Kilburn's teams used these AI models to map a hidden ring fault system, an arc of fractures circling the caldera, channeling seismic energy in ways earlier models never predicted. This ring fault, revealed by deep learning analysis of seismic swarms, means that shaking and pressure can focus along specific underground lines, amplifying risk in zones once thought safer. The same research overturned assumptions about the volcano's anatomy. Seismic tomography and fluid movement studies now place the primary magma reservoir just 2 to 4 kilometers below the surface, far shallower than previously believed. Kilburn's group demonstrated the consequences with a simple mocha pot, the stovetop coffee maker familiar in every Neapolitan home. In their lab, they mimicked the caldera, a sealed chamber, water below, heat rising. As pressure built, steam forced its way through the weakest point, sometimes with little warning. The analogy is striking. Campi Flegrei's caprock acts like the mocha pot's lid, sealing gas and heat until the pressure finds a way out. These findings have rewritten the evacuation playbook. Old models promise days or weeks of warning before an eruption. The new science suggests that once this shallow, gas-rich system reaches a tipping point, the transition from unrest to explosion could take place in hours or even less. AI-driven microquake tracking and lab experiments both point to a window so narrow that the region's evacuation plans, designed for slower-moving crises, may be outpaced by the volcano itself. For the 500,000 people living above the caldera, the margin for escape is shrinking, and the challenge for authorities is now measured not in days, but in minutes. In October 2024, as ground temperatures and gas emissions reached record highs, the region's defenses showed their limits. During a week of heightened seismic activity, one of the main monitoring stations near Solfatara went offline after a power surge tripped its thermal sensors. Engineers scrambled to restore the feed, but geothermal heat had already warped circuit boards and melted insulation inside the equipment shed. For nearly 4 days, real-time data vanished from the network, leaving scientists to work blind while the caldera's pressure continued to build. On the streets, the situation was no better. After a magnitude 4.2 quake cracked the surface of Via Napoli, city crews poured asphalt into the fissures overnight. By dawn, a new vent had burst through the repairs, sending steam and sulfurous gas into the morning air. The road, a critical evacuation route for Pozzuoli's red zone, was closed for emergency work just as authorities reviewed evacuation plans for 500,000 residents. Each closure forced traffic onto smaller, winding streets already choked by parked cars and market stalls. Maps of official escape routes began to look like wishful thinking, with arrows pointing through roads that could vanish beneath the next vent or sinkhole. Civil protection agencies ran drills, but the scale overwhelmed every scenario. Moving 500,000 people out of the red zone would require hundreds of buses, open highways, and days of clear warning. The reality offered none of these. Families received text alerts with instructions to stay ready, but many knew there was nowhere to go if the order came. The evacuation plans, designed for a slower crisis, now faced the possibility of being overtaken by events unfolding faster than any system could manage. The gap between scientific warning and practical escape grew wider with every outage, every blocked road, every unanswered alarm. In late September 1538, the land west of Naples began to tremble and swell. Over just 4 days, earth that had been vineyards and pastures heaved upward, splitting open with cracks and venting steam. By the end of the week, a new hill, Monte Nuovo, stood 133 meters high, where none had existed before. The coastline shifted so dramatically that fishermen found their harbors transformed, and entire villages were forced to move as the ground kept rising. Historical records describe the sea boiling near the shore, the air thick with sulfur, and days when the sun was blotted out by ash and smoke. Monte Nuovo's eruption was not the largest in Campi Flegrei's history, but it was sudden, violent, and reshaped the landscape almost overnight. The deeper history is even more sobering. 15,000 years ago, Campi Flegrei unleashed one of the most powerful volcanic events Europe has ever known, an eruption ranked at VEY 7 on the volcanic explosivity scale. Ash from that explosion blanketed the Mediterranean, changed the climate, and left behind the vast caldera that now sits beneath modern Naples. That ancient blast dwarfed even Vesuvius's destruction of Pompeii, scattering debris for hundreds of kilometers and carving out the basin that defines the region today. These are not distant legends. The coastline's jagged outline, the layers of volcanic tuff in every hillside, and the sunken ruins along the shore all bear witness to the caldera's capacity for abrupt, catastrophic change. The record is clear. Campi Flegrei does not give centuries of warning. In the past, the ground has shifted, the sea has bubbled, and within days, the landscape itself has been rewritten. Today's unrest echoes these patterns, reminding those who live here that the system beneath their feet has a history measured not just in centuries, but in cataclysms. In June 2025, Campi Flegrei experienced ground uplift totaling 1.4 meters and a magnitude 4.6 earthquake, while gas emissions surpassed 4,000 tons of carbon dioxide per day, both figures confirmed by Italy's National Institute of Geophysics and Volcanology. These numbers, combined with record vent temperatures of 128 degrees Celsius and sea surface bubbling logged by fishermen, signal a level of unrest not seen in decades. Yet, despite advanced monitoring and new scientific models, experts still cannot pinpoint if or when a major eruption might occur. Historical records, such as the rapid Monte Nuovo eruption of 1538 and evidence of a VEY 7 event 15,000 years ago, show how quickly the system can change. Today, over 500,000 people live atop the caldera, facing a threat that remains only partly understood. The facts are clear. Volcanic pressure is rising, monitoring systems are strained, and the timeline for any warning may be short. Campi Flegrei's future is uncertain, but its risks are now impossible to ignore.